checking, okay, angle in a semicircle, then D1 is going to be equal to 90 degrees. Okay? The reason is not theorem 1, it's the converse. Line from center to midpoint of chord. Because we want to prove that D1 is 90. It's not 90 until you prove that it is 90. Okay? So the reason will be line from center to midpoint of chord. That's your reason. Okay, so if you prove it this way, then from here, it therefore means that angle C1 will be equal to D1. Therefore, FC is parallel to OD. The reason corresponding angles equal. Okay? Corresponding angles equal. There's no need to specify it. That's why I'm saying if you familiarize yourself with the acceptable reasons based on examination guidelines, you understand that it will become very easy. This is how you just write it. And it's there in the examination guidelines. Okay? Right. So D1 and C1, they are equal because they are corresponding angles. Therefore, FC is parallel to OD. This could be one solution, or you could use the midpoint theorem by saying FO is equal to OE. The reason it's radii. There's no need to write anything else. It's radii. Okay? That's it. CD is equal to DE. That's given. Okay? Therefore, FC is parallel to OD. Your reason, midpoint theorem. Then you are done. Okay? So this was question 10.1. Okay, and the other thing, your neatness is of utmost importance. Okay? Geometry is one of the most challenging topics to mark. So, if your work is haphazard, you are making things difficult for a person who's going to mark it. Okay? It needs to be neat and your layout must be straightforward so that the person who marks will be able to follow what you are writing. Okay? Because the moment, if I see something which is not in order, a lot of scratching and all this stuff, I'll tell you from experience, you end up having a negative perception towards what you're marking. And that can have an effect. Okay? That can have an both of the layout. If the work is neat, it makes things a little bit easier. Okay? Remember, at the end, it's not Mr. Chiponda who will mark your work. Okay? Remember that. Okay, so this was the first part of the question. Okay, so the first part of the question. Okay, now you need to know that if you are asked to prove that lines are parallel, either use your geometry of straight lines from grade 8 and 9, you can use the midpoint theorem, you can use the proportion theorem from grade 12. Okay, that's it. There's no need to get nervous when you see a question asking you to prove the lines are parallel. Right, then 10.1.2, we're supposed to prove that DOE is equal to BAE. Okay? Angle DOE. Okay? That's the angle there. So the angle is this one. Okay? Is equal to BAE. Now, BAE, so we are talking about that angle. Okay? Now, the good thing is, in the first part of the question, we have already proved that FC is parallel to OD. Okay? So you can see that this angle here is going to be equal to angle F. Okay? Also, in the question, it's given that AFBC is a cyclic quad. Okay? It's given that AFBC is a cyclic quad. So, if that's a cyclic quad, AFBC, it means that angle A and angle F are what? Are equal because they are angles in the same segment. Okay. So, the first thing I'll write it this way. Angle DOE is equal to angle F, because they are corresponding angles. Okay, this is very important. Right, at this stage in grade 12, please don't forget that whenever you write that angles are corresponding co-interior alternate, you need to state the lines that are parallel. You need to write down the lines that are parallel. If you just write corresponding angles and then you are done, you lose a mark for the reason. The lines that are parallel, they must be stated. So FC is parallel to OD or to DO. Okay? Then we have angle A. Okay? I'll just call it angle A. It's equal to angle F. Okay? They are angles in the same segment. Okay? They are angles in the same segment. Now, once you have got two statements like this and there is a common angle, you can then say therefore. Therefore, angle D, okay, let me write as ABE. Okay, BAE rather. This is BAE. That's BAE. Sorry, I wrote this in the wrong place. Okay, that's DOE BAE. Yes, B DOE equals BAE equal to DO. Okay. All right. So this was 10.1.2. 10.1.2. Okay. So your layout is very important and your neatness is very important. Okay? Okay. So you can start by doing that, identifying the corresponding sides and the corresponding angles from a given statement or equation. And then you move on to writing or proving that those two triangles are similar. You should not get nervous. Once you see something like this, it means either use proportion theorem or similar triangles. Let the question guide you. Okay. Most of the time, these questions have got a connection. What you do at the beginning of the question is got a connection with the next questions. Okay? You never get a question which is not connected to what's there. Everything is connected. Right? So this is how you could do the question. But let's move on to the next one. Yes? Of the circle. Okay? Then I'll say therefore AB over OD is equal to AE over OF. Then I just multiply there. So we get AB times OF is equal to AE times OD. And then you are done. Yes? In most cases, right at the end, the question that will be there as a connection with the proof that you did at the top in terms of similar triangle. In most cases. So here, we have got that BE. For me, when I see the question, I've got that BE. So if I go back to my ratio, you see that this one, sorry, to my statement there. Because I've got this BE, okay, I'm going to try and use that BE. Also, I've got FE, right? FE is a diameter, and FE is 2 times OE. Okay? I've got the OE there. When you're doing the question, you also have to think. Okay? You also have to think and see what you got and what you're asked to do. But let what you are given guide you. So here, let this statement here guide you. Okay, that's what you're supposed to prove. Look at it carefully and see how you can prove it based on all the information you got. So, and also we have a ratio. Okay, we have a ratio. Now I'm going to start by using the ratio. If I use the ratio, right, remember our triangle is going to be A or D. Okay, so I'm going to say in triangle A or D, right, AT over TO is equal to AC over CD. All right. It's a good thing that I gave you that work to do at home, and then I saw some of the reasons you are writing. Please don't write proportion theorem and forget to write the lines that are parallel. If you write proportion theorem and you don't state the lines that are parallel, it means your reasoning is incomplete. Okay? That's why I said refer to the examination guidelines. That's why I made sure that I posted them on the school portal and on the Google Classroom. For the school portal, it's for all the grade 12. For the Google Classroom, it's for this class. There are two reasons that you must give for the proportion theory. The first one, which I like, is line parallel to one side of triangle. Okay? This is the main one. But if you like to write proportion theorem, don't forget to write the lines that are parallel. That's a very common mistake. So if you decide that you want to say proportion theorem, then you need to state the lines that are parallel. Here it will be FC is parallel to OD. Okay? So I'm not going to impose to you that, okay, write line parallel to one side of triangle. It's your choice. But if you use this one here, be careful of forgetting the lines that are parallel. Be careful. Because that's a very common mistake. Okay, then the other thing that I need to add on the diagram, we are given that ratio AT is equal to 3TO. Now what that means is, this one here I can call it Y, and that AT I can call it 3Y. Okay, it's my choice in terms of the letter that I'm going to use as a constant. So I want the ratio AC over CD, that will be equal to 3. Okay, 3y over y, that's 3 over 1. Okay, then if I go back to the diagram, my AC, I can call it 3x. My CD will be x. My DE, because it's equal to CD, that will be x. Okay? Right? Now I want you to know that the memoranda from the department does not show you the concept of the constant. Okay? They don't indicate it. You just see the ratios. And sometimes you wonder, where did they get them? This is where they come from. Okay? So we have got that. Once you get here, then it becomes easy now. So let me go back to my similar triangle. Right, before I carry on, okay, let me carry on here. That's CE. I'm sure you can see that CE, okay, is going to be equal to what? 2x. Okay, CE will be equal to 2x, and my AE will be equal to 5x. Okay? Obviously, if you want to write the reason why C is equal to 2x, but that's not. Okay, let's write it. Why this is true is because CD is equal to DE, and this is equal to x, and this is given. It's given based on that part. Okay? Then let me go to my similar triangles. So I'm going to choose these two ratios, okay, BE over DE. So, so I'll say BE over DE is equal to AE over OE. AE over OE. Please, you have to write a reason. This is based on similar what? Triangle. Right? We have got our BE. Now, DE, if you look at it, okay, you can see that the DE is half of CE. So, I can write this as half CE. Okay, then my AE, I can write AE in terms of CE. Because I want to create this CE squared. Okay, that's the objective. So I've created the first CE by using DE. The second CE, I'll use AE. Okay, so if I use AE, let me just write this down. CE is going to be equal to, it's 2 over 5 of CE. Okay, so it's 2 over 5, sorry, of AE. So what this means is AE will be equal to 5 over 2 CE. So that will be 5 over 2 CE over. Right. Can I have your attention? The OE is half of FE. Right, but let me write it down here. OE is equal to half of FE. The reason diameter is equal to 2 times radius. Okay? So where there is OE, I can put half FE. Okay? Right? And should be smiling. Those two cancel. Right? Cross multiply, then you get BE times FE equal to 5 over 2 CE squared. Then you multiply both sides by the 2, so you get 5 CE squared equal to 2 BE. Right? I like these questions because you cannot make a plan. Okay? And then you are done. Right, so make